Okay, everyone, thank you for joining me for this quick refresher. I know that you have all seen this, especially the ones coming out of Cal. You've just recently seen a lot of this. But I just want to go over the things that I really see students missing a lot or having a lot of trouble with. It's really things that you've done just a lot, but a lot of the concepts that you're going to be looking at in this class are very new and cumbersome when you first come into contact with them. So these are just some of the things that are left out. And so I really want to highlight them and kind of get these in the forefront of your mind. Right here, you're going to have a conversion factors page. You're going to have this all semester long and the ability to use this on all of your assignments. So I highly recommend you print it out and have it with you. Because this is an online class, you're not going to have the ability to have, I mean, maybe you do have 5 screens. I'm going to assume that you do not. So trying to use this in conjunction with your notes and things like that, that's just a lot to have on one screen when something is timed. So I would highly recommend you print this out and have it with you because you are going to be looking at this a lot throughout the semester. So what I want to go over today is just some temperature relations, and then as well as maybe plugging into a force formula here, then going from an EE to an SI or SI to EE, and then at the end to cover the exponents portion of the integral. So not the entire integral, but just the exponents portion of it. I know that you guys know how to solve all of these things as well as the integral, but the exponents portion of the integral is what I see students really mess up or not get all of the details in. So I just kind of want to go over that also so that you can come back and refer to this all semester long if you have any questions or you just want to double check something. So let's start with this temperature relations here. And let's start with a problem. Whoops. Okay. Sorry, guys, my pen is having some issues. Okay, so if we're given a temperature of 122 degrees Fahrenheit and we need degrees Celsius and Kelvin. So if we come over here to the bottom right of the screen and we see our temperature relations formula, we don't have something taking us from Fahrenheit to Celsius or Kelvin, but we do have it taken to Rankine. And then when you look in the rest of the formulas, you can see that from Rankine, we can go to Kelvin, and then from Kelvin, we can go to Celsius. So a lot of times you're going to have to find a unit or some other number that you're not actually looking for, but you need that number to then find what you are looking for. So let's do Fahrenheit to Rankine. So we've got 122 degrees Fahrenheit equals temperature Rankine minus 459.67. We'll just get that to the other side because we want to isolate this because this is what we're looking for. 459.67. And then that equals 581.67 degrees Rankine. Okay, so we've got that, but that's not actually what we need. What we need is Celsius and Kelvin. So from the Rankine, we know from our formulas that we can get to Kelvin with that 1.8 multiplier. So we'll do 581.67 degrees Rankine equals 1.8 Kelvin. We'll divide by the 1.8, again isolating this Kelvin because that's what we need. Divide by 1.8, and then that's going to give me 323.15 Kelvin. Okay, and so that is a answer that we need. So I'm going to box it in and just put a check mark just so that I know that that's what I've got. And the only one that I'm working on now is Celsius. And so from Kelvin, I can get to Celsius. So my temperature degrees Celsius equals my Kelvin, which is 323, 15 Kelvin, minus 273, 15. And then that is going to give me 50 degrees Celsius. Okay. That's my other one. Got all check marks on everything I'm looking for. So that's my answers. Obviously, these go away. Just in case you need to see that. And then that. And it's just not wanting to go. Okay. All right, perfect. So let's move on to, let's do a force problem. Let me erase all this. Okay. 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 So let's do a force problem. What we've got here is a force formula. So we've got 1 Newton equals 1 kilogram in meters per second squared. So there's not a multiplier. So it's a really easy one. As long as what you are given is in, your mass is in kilograms and your acceleration is in meters per second squared, you're going to be good. It's going to just equal whatever it is in newtons. So let's do one of those just so that we can kind of get familiar or re-familiar with the formula, and then kind of move to one that's just a little bit more difficult. So we've got SI units, which is what this is, and we've got Newton's second law, which is force equals mass times acceleration. And so what we are given here is actually, move over here a little bit. Given is a mass equal to 13.3 kilograms and an acceleration of 1.20 meters per second squared. Okay, so in here, we're just going to plug in because we've already got the formula right here is force times mass, force equals mass times acceleration. So right here, so 1 Newton of force equals 1 kilogram times meter per second squared. So that's what we've got. Our force is in kilograms, we've got it. Our acceleration is meters per second squared, we've got it. So we're just going to multiply across, and that will be our newtons. So our force in newtons, because we know that our units are good, is, what is our mass? 13.3 kilograms times 1.20 meters per second squared, which is 15.96 newtons. Okay, so that's our answer. That's a really easy one. So let's look at, let me see if I can just zoom out. Yeah, okay. So that's one. So let's do EE units now. Okay, so EE units will be a little bit different because this does have a multiplier in it. So you see, we'll use this one, this 32.174 pound times feet per second squared. So let's write that conversion up here. So we've got 1 pound force equals 32.174 pound times feet per second squared. And then to make this whole thing a conversion factor, we just need to divide and get this to this side. So really it's 1 pound force over 32.174 pound feet all over second squared. So kind of like this. Okay, so this is our conversion factor. I know that that looks a little kind of crazy a little bit, but once you start using all of these, it'll just kind of become second nature if you haven't done these things in a while. So let's just plug in like we did before for our SI units. We're going to use the same given. So here's our formula again, and then our given is mass equals 13.3 pounds this time, because we're in EE units. And then acceleration is 1.20 feet per second squared. So if you see our formula, we still have the same units in there, so we have the correct units. We're not converting meters to feet or anything like that, but we are needing to incorporate this 32.174 conversion factor into here. So to do that, let's just do our mass, which is 13.3 pounds, times our acceleration, which is 1.20 feet over second squared. And then this is where our conversion factor comes in. So we're just going to multiply that 1 pound force over 32.174 pound feet over second squared. And this is when we are canceling out. So this is all in the denominator, and if we were to multiply across, all of this would end up in the numerator. So this cancels out. This cancels out with this. And we're ending with that pound force, which you see right over here per our formula is what we need to have. And so then if you multiply across, this 13.3 times 1.20 times pound force will give us 15.96 pound force over, because this is what's left in our denominator, 32.174, which then gives us 0.4961 pound force, and that's rounded. Okay, so this is our EE units. Okay, all right. So now that we have that, and you'll have examples, I will post an assignment for you guys to do some of these. Actually, everything that we're working, you will have an assignment on, just so that you can work through them as well, aside from the integral. At the moment, I'm not going to put an integral on there. I may find a very simple one, but right now I'm leaning towards not putting one on there, just because I know a lot of you are just coming off of doing a bunch of those. So let's get rid of all this. Okay. And let's do a really simple conversion from EE to SI, because you will be given problems that have both units in the problems, or you'll be given data, and some of the data is in EE and some of the data is in SI, and you'll have to convert from one to the other. So let's just do another simple one. My pen is just crazy. There's a button on the side that I think I keep clicking that's just bringing everything up. Okay, so EE to SI, we'll do that one. So EE, let's say we have 100 feet per second. Okay, so real easy. And we need to get it to SI, we'll do kilometers per hour. Okay, so what we're going to do is we're going to start off with our 100 feet per second. Let me just start this over. That one's getting rough. Okay. Feet. And, oh my gosh, I'm going to end up cutting out all of my notes. Okay. Feet per second. I bet it'll get better by all of these lectures being posted. Okay, so we need to get rid of the foot because we're trying to get to kilometers per hour. So we need to get to meters. So this is the point where we're going to go from EE to SI in regard to the feet, right? Because seconds are that's just international. So we've got 1 foot is equal to 0.3048 meters. And then we need to get from meters to kilometers. So we've got 1,000 meters is equal to 1. Oh my gosh, it's frozen. Good night. Okay. Okay, and so we've got the units portion. Sorry guys, I don't know what's going on. Okay, so we've got that portion, and now we need to get from seconds to hours. So I'll do it the long way, but you're more than welcome to just go straight from seconds to hours. I'm going to go with minutes. So 1 minute is equal to 60 seconds, and then 1 hour is equal to 60 minutes. And so now you can start canceling out. So minutes, meters, meters, seconds, seconds, feet, feet. And all we're left with, you see our units are only kilometers per hour. So we've got what we need here. Now we just need to multiply across. So if you multiply the 100 times 0.3048, 160 and 60, you're going to end up with 109,728 kilometers. And then you've got, when you multiply across on the denominator, you've got 1,000 hours. And then obviously when you divide by that, you're going to end up with 109.728 kilometers per hour. So it's just a really easy example. Of course, you'll have some of these too. And so now let's do the integral, or the portion of the integral, the exponents portion of the integral. So there's 2 steps. Good Lord. Come on. Okay. I need to put some tape over this button or something. Okay. So step 1 is to flip and add a negative exponent. Okay, so what does that mean? Let's do 2 examples. So 1 over x, if we're flipping it, it's going to be x, x over 1 is just understood as an x, and then add a negative exponent. So we know that there's an understood 1 up here, we're just going to put a negative. So that's all that means. You flip it, add a negative to the exponent. And let's do one that already has an exponent, or that has an exponent other than 1. So it'll be x to 2, and then x negative 2. Okay, and so then step 2 is to add a plus 1 to the exponent and bring entire exponent down. Okay. So let's take those two examples again and work them from start to finish with both of these steps. So we started with 1 over x, and then that takes us to flipping it, which is x, takes us to the negative exponent, then adding the 1, x negative 1 plus 1, and then bring the entire exponent down to the bottom. Negative 1 plus 1, bring this whole thing down. So this is usually where students have trouble. with solving their integral. But again, you have a calculator. You're more than welcome to use it. You're more than welcome to use the integral solver on your calculator. But sometimes students do it by hand. I know some students find it a little bit faster. So this is just a portion that people kind of get tripped up on. -1 plus 1. You'll see this in the work formula. So let's do this one. X2. So flip it. X2. X -2. X -2 plus 1. And then X -2 plus 1 over -2 plus 1. That's the same thing. Bringing it down. And then X -2 plus 1 over -2 plus 1. Okay, so that's what you're left with. So this is just, remember guys, this is just the step. This is just one of the steps of the integral. We're not talking about pulling out constants in this example. We will later in the semester. So we'll have things like constant pressure, things like that you'll pull out of the integral, and we will solve the entire integral, but just I wanted to highlight the problem that students really seem to get stuck on. So look for the assignment, come back to this, look at it, print out your conversion factor sheet. It's extremely valuable. You'll need it for the entire semester for all of your assignments, and you'll have it. So come back to this if you need anything, and thanks for watching.